Okay, this is the first question for SL Section B of 2024 Time Zone 2, Paper 2. It's a normal distribution question. And according to the model, length between 41.4 and K is within one standard deviation from the mean. What that means is simply the mean minus a standard deviation and the mean plus a standard deviation. Right. So that's where 41.4 come from, because it's really what's the mean? 45.6 minus a standard deviation. So the other value would be the mean plus a standard deviation. That's what they mean by within one standard deviation of the mean. And the probability that something picked is greater than 48, so that's pretty direct. Normal CD. Where's my normal CD? Oh, here. What's the mean? Standard deviation greater than 48, 0.28385. It's known that 99% have lengths greater than x fan x, so that's also pretty direct inverse norm. So 99% is bigger than x fan x. So how do I do inverse norm? So it's bigger, which means for your calculator you should choose like right tail for most calculator. Then you put in the area to be 0.99 on the right. If your calculator have no choice, then it means you have to put area to the left, meaning you have to put 0.01, because total probability is 1. 1 minus 0.99 is 0.01. So x would be 35.83. Alright, so this dude should be straightforward. Now consider a random sample of 100. That sounds like binomial. For the expected number, that would have lengths between 40 to 56. That means you simply find the probability that one carp, is that called carp? I don't know how to say that. One of those is between 40 to 56, 0.902, and then you multiply that 0.902149, and then you multiply that by 100. That would be the expected number. Right. So it's like on average, you expect 90 of them to be between that. It's okay for expected number to be decimal, even though in real life you can't have 0.2 a carp. The probability that in a sample of 100, exactly 95 is of this length. Now this is a binomial. So this is binomial. The number of trial is 100. Success probability is the probability that one carp is between 40 to 56. So it's 0.902. You want y to equal to 95. So that's, where's my binomial? Here, number of trials 100. Success probability 95. Then you can do this 95. 0.0381 for reason quick. In a large sample of carp, the length of each fish is measured and corrected to the nearest 0.1. Find the probability that some fish, that one random fish is recorded as 56.6. Oh, that's a new type of stuff that they ask. Let's go back to, I mean, if you're from UK and you've done IGCSE, then you've learned something called upper bound and lower bound. Is actually that. If you have not learned that, then that will be quite difficult for you to understand what's going on. Because in a normal distribution, normally the probability of getting an exact number is supposed to be 0. Right? But that's not the question here. The question is not what is the probability that the fish you catch is exactly 56.6 cm long. If the question is that, it will be 0. But the question is, what is the probability that the length is recorded as 55.6? Well, then you think, what would be the actual length of the fish, and yet it will be recorded as 45.6. Why am I reading the number all wrong today? Okay, let me say that again. What would be the actual length of the fish so that it will be recorded as 45.6 if the measurement is corrected to the nearest 0.1 cm? Okay. Well, it's likely to be a range, and if you think about it, it would be when the fish is between 45.55 long and 45.65 long. Right? Because if you correct this number to the nearest 0.1 cm, then you would say this is a 5, so you add 1 to it, so it will be 45.6. Any smaller than this, let's say 45.54999, then when you correct to the nearest 0.1 cm, you will look at this digit and say, oh, this is less than 5, so we do not add 1, so it will be recorded as 45.5. So in order for the fish to be recorded as 45.6, 45.55 is the smallest possible value. Alright. Now what about the biggest possible value? Now I know what you're thinking. You're thinking, hey, if this is 5, then it will add 1, and it will get 45.7. Well, that's why I didn't put an equal sign here. There's no equal. As in, if it's exactly this, then it will be recorded as 45.7. But as long as it is a tiny bit smaller than 45.65, so imagine like 45.64999, then when you correct to the nearest 0.1 cm, you look at the 4, and it will still record as 45.6. Okay, so this is the range, and you want to find the probability that an actual fish have a length of this range. So again, this is a normal distribution. And what was the mean of the fish? 45.6. And what am I trying to say? Oh, and when you type to the normal distribution, whether this is equal or not actually make no difference. So when you write the lower bound, upper bound, it kind of make a difference, but when you type to the normal CD, it makes no difference. What's the answer? 0.00094,984. I guess I'll write more than 3 sig fig. They won't penalize you for that.